Welcome back, my friends. It's been a while since I recorded a bootcamp video. You're probably wondering, why do I have a hat in the house or in this hoodie? It's a good question. I'm a little bit sick, but I promised some people on Discord that I will continue this bootcamp, so here we are. Today we will be discussing two things in this video, a viewport and the CSS units, and I've decided to combine them because both subjects are quite small, so they can fit a single video and can be explained in a reasonable amount of time. After we finish this video, a next video will be actually building a project with all of these things that we've learned so far in this bootcamp, which was, CSS box model, display and position properties, etc. So I'll try to build a couple of layouts with you and just showcase that even with only a few of these utilities in CSS, you can do quite powerful things. So today, viewport, CSS units, so let's get started. So let's first start with the viewport. Viewport is essentially a fundamental concept in web development and web design, because viewport is a term that defines or describes a visible area of your website, right? So for example, if we take a look at this browser, let me just switch to the main screen. So if you take a look at my browser here, right, the viewport area would be everything here besides the browser details. So the viewport would be basically this content in here, right? It would not include the actual bookmarks bar, search bar, or anything browser related. So viewport essentially is a usable and visible area of your website. And now the more emphasis on visible is because keep in mind that if I scroll down to the bottom of this page, this is now my viewport. So it's not the entire page including the scroll, it's the visible part of the page. So that's your viewport. For example, smaller the device size, so if I take my iPhone here, well then my viewport would be, so for example, if I open up Programmer Network here, this is Programmer Network on my phone, right? So the viewport would be, well, the width of the viewport would be the width of the device screen and the height as well. And then excluding these controls here, right? So excluding the all the controls that I have on my phone, like the browser navigation buttons, bookmarks and stuff like that. So that would be the viewport. Now, of course, also when we get to the JavaScript part of this bootcamp, this is gonna become even more increasingly important, because you will be writing code that will be calculating certain sizings dynamically based on the viewport. The viewport is going to be one of the variables in your equations, right? You will be dynamically, or you will be writing code that will dynamically calculate certain things based on the size of the screen. So this is, while right now this is not that important, believe it or not, it's going to get increasingly more important when we get to more complicated things. I have included the viewport link in here, so you can take a look at it, of course, and I urge you to skim through this. Many of these things you will not understand because we haven't gotten to the JavaScript part, but you will notice here that there's some mention of JavaScript and how we can, in the browser, figure out our current width and height of the screen. So if I actually inspect this and just get over here, again, please ignore this, you're not supposed to understand what it does, but if I open the console in our developer tools, you'll notice that my client width is 1453 pixels. If I copy the inner width, it's 1463, and then outer width is this, right? So as you can see, we are getting some numbers based on some variables, and the browser is going to giving this to us. But again, let's stop there. So just read a little bit of theory here, and even more important, I've aggregated this information into more digestible stuff, so you probably want to read this document. But as we can see, that the viewport is fundamental in web design, especially for creating responsive layouts. We're gonna have actually a video on responsive design as well. Understanding what the viewport is and how it affects web design is key for any aspiring web developer. So definition, what is a viewport? Is the user's visible area of a web page. It varies with the device, smaller on mobile phone than on, so as I said, if you have a smartwatch, mobile phone, desktop, a TV, the viewport is going to be bigger or smaller, right? Responsive design. A key aspect of modern web design is to make websites look good on all devices. The viewport plays a critical role in achieving this responsiveness, and that is what we also said. Then there's some other concept, viewport versus window. The window itself is the whole browser window, so as you can see, it refers to the entire browser window. including the browser Chrome, like the address bar, tabs and stuff. So this whole thing in the top, while the viewport doesn't, as we said, only the area where the web content is displayed. It's what you actually see of the website. How do we enable the viewport? How do we say to our website, hey web page, I want you to respect the viewport. How do I tell my web application, hey, this is how you should be treating the viewport. This is what viewport is. We do that with adding this meta tag. So this HTML meta tag called meta. Meta tag, yes. And then we set some attributes in that tag. So we say width is the device width, and we have initial scale is 1. So what do these mean? Width means the viewport width should be the width of the actual device. So on phone, as I said, on my phone, this would mean the width of the screen. On this screen, you can see it's this width, right? Initial scale just sets the default zoom level of the web page. As you can see in the browser, you can zoom in and out. So right now I'm zoomed 100%, 110%. Now I'm zoomed in 200%, right? So in my career so far, I don't remember, maybe I have, but I don't think that I've ever set this to anything other than 1. So it's very, very rare that you're going to use this. It's in fact very rare that you will ever touch this again. And it's also very rare that you will ever do this on your own, because most modern frameworks and stuff, once we get to that part, do set this already by default. So you will not be doing this manually yourself, right? And then we have viewport width and viewport height CSS units. Let's wait with those for a couple of minutes, because we will switch now to CSS units, and then we're gonna explain these two as well. But I think they're very self-descriptive. And then we go into the CSS units, and again, we're gonna start coding. I just want to get you to understand some of these things. And then we have pixels and percentages EM, so I'm gonna explain all of these now. So let's actually go and do some work. So I've created a document here, the HTML document. I already opened it in the browser just so we don't waste a few seconds. And as you can see here in the meta, in the head, I've already added this meta tag right now. Next natural question that you should be asking is, Alex, what is meta? What is the meta tag? What is metadata? What does that mean? Well, I hope that would be your natural question. So you can go to Google and say, what is metadata? Yeah, there we go. Metadata is defined as the data providing information about one or more aspect of the data. So metadata is data that describes the data itself, right? So if we translate that to meta tag in an HTML document, we can assume that the meta tag describes the document itself. So in this context, this meta tag says, hey, this document should use this character set, it should use UTF-8 encoding. This thing should set the viewport to this. And then we have the title. This is not a meta tag, but you can see we can have many meta tags out there that describe the document itself. These things are nowhere visible of the page. They're like some sort of a inner description of how document should behave, right? So now we have told this document to actually respect the viewport, and that the viewport width is the width of the actual page, right? Of the device itself, sorry, because the device width. So if it's mobile, again, it's going to be this width. If it's a screen, like my current screen, it's going to be this. You get the point, right? Okay, great. So now when you know what a viewport is, let's talk about CSS units, right? So I think that would be the next natural thing to do. So as you can see in this document here, I started with the most simplest pixels, right? Pixels are the most basic unit. They are fixed size units that consist across devices, ideal for when you need precise control over element sizing, like borders or widths, blah blah blah, right? So a pixel essentially is the most common unit that you're going to be using, and pixels are basically absolute in that sense, is that if your screen is 1080 by 920 pixels width, right? If you say that your element is a width of whatever 600 pixels, right? Well, then it's going to occupy 600 minus whatever the total amount of pixels you have, right? And actually, because it's maybe too much theory, so I'm going to just link a document here, this style that I created, and let's take this heading 1, and let's say font size, 100 pixels. So if I go here, you will notice that this heading 1, now let me zoom out because I zoomed in a lot. You will notice that the height of this is 100 pixels, right? So now I've said that the font size is 100 pixels, so how big this element is now depends on other factors like the CSS box model and stuff, right? But we know now, because this is 100 pixels, that it's never going to be dynamic. So if this, my screen might have different pixel density, meaning this can be an 8K screen, which means it's going to have, let's say, 4 or 5 or 8 times more pixels. So this will look, of course, different, because, if you multiply the amount of pixels you have, then this element would clearly look smaller because there's so many more pixels on the screen, right? The resolution is a lot bigger, right? But the pixel itself, there isn't really much to say about it. It's a fixed size, and it's the most commonly used unit. And it's not really dynamic relative to anything else. So it's always going to be, if you set something to 50 pixels, like that, right? So if you use the px unit, that's always going to be that, right? Now, we can get into more complicated units, right? Dynamic units like percentages, EMs, REMs. And these are dynamic. They're dynamic in a sense that they depend on size of some other elements. So as you can see, we have the M unit and we have the REM unit, right? REM unit, as you can see, is the root EM, and M unit is relative to the font size of the element. So let me show you what that means. So if I go back to my CSS file and I say that, let's say that the font size of this is 2EM, right? Let me show you now how this works. So if we inspect this element in our developer tools, we have a developer tools video if you haven't watched it, you'll see that the font size now here says 2M. And we can see that the size of this has changed, right? So actually, if we make it 4EM, it's going to be even more clear, right? So how does the EM unit works? Well, EM, and REM are both multiplying units. They multiply someone or something. So EM, whenever you set something to EM, it's going to try to find the closest parent that has the font size set, and then it's going to multiply that. So for instance, because we don't have such a thing, H1 is going to search for all of the parents, and eventually it's going to get to this HTML tag here, and this HTML tag in the browsers by default has a font size set, right? So it's going to multiply that one. And this HTML, this thing here has, if I click here, show all, and if I just move my camera, if I come here to font size, you'll see that if you remember, we spoke about user style agents in the browser, and that the browser comes with the default styling. You'll see that the HTML tag, this guy here, has a font size set to 16. So if you logically now think about this, right, this being 4EM, this is now multiplying the 16 because HTML, basically the document itself, is the closest element that has the font size set. So this is going to be 4 multiplied by 16, right? If we decrease this to 2, now this is going to get smaller. Now the size of this is 32. 16 by 2 is 32. But let me show you one thing. So if I go back to this div here, and I give it some class, let's say, let's give it a class container. And let's see what happens if I actually set the font size in container. So I say container, and I say font size, I say 10 pixels. Let's see what happens now. Okay, wow, this got smaller. Why? Well, because now the H1 has found a parent that has the actual font size, and it's this div here. You can see the container has the font size. So the H1 now is actually multiplying the font size from here, which, as you can see, makes this 20 pixels instead, right? So that is the difference, right? So the EM and REM, and we're going to get to REM in a second, are units that depend on font size of some other element. So we've just learned that EM depends on the closest parent that has the font size set, right? So as you can see here, this is where our H1 is inside of the div, and the div has the font size. If it didn't, we would go to the body. Does the body have the font size set? No. And then we would go to the HTML document. The HTML document by default has 16 pixels font size, hence 2EM would be 32 pixels, right? And now we get to the point of rem, right? So if I switch this to rem, as we said, as I wrote in that document, rem stands for root em, and rem only and always multiplies the root element, which is the HTML document, right? So that's what it stands for. So if I come here and I change the default HTML font size from 16 to, let's say, 20, now you can see that my multiplier, the rem, multiplies 2 by 20 pixels. So this is now 40. If I change this to 60, this is going to be, you figure it out, it's going to be 120, right? So rem is, you can always use, if you use rem, you're always multiplying the actual root element, which is the HTML. So you can multiply the whole, you can build a layout that always multiplies the same value. So the rem doesn't care about the container in this context, it neglects it completely, nor it cares about any other parent, it just always goes to the HTML itself. Now the very logical question would be, why do we need dynamic units, right? Because so far this is fine and it's great, and you understand that some of these units, unlike pixels that are basically very static, fixed, these are dynamic or relative to something else. Why are they useful? And they're useful for responsive design. So basically, once we start doing responsive design in one of the next videos, you will notice that we can build the layouts in such a way, it's like, hey, when I resize, when I open this website on mobile and when I open it on desktop, I want certain values to be different. So we will be able to control the size of this or some of the other divs or containers, and then the rest of the layout is going to kind of get either smaller or bigger based on what of the responsive roles that we set, right? So this is why we need these units, because we can then think a little bit differently. Instead of thinking about pixels all the time, we can think about just increasing or decreasing the size of elements dynamically as the browser increases or decreases. I'm going to show you that in the one of the next videos. And I think if we go to one of the, I think we have 3 more units to explain. We have EMs and REMs. Okay, so we explained that. We have percentages, right? And percentages should be very simple to explain and understand. Percentage just means percentage of something, right? So let's do that, right? So if I go here and remove this stuff that we have and remove the CSS, I'm gonna create 2 boxes, right? I'm gonna say, and I'm gonna give them a class of CSS class box, and then box, and then I'm gonna actually put them inside of some container, right? Here I'm gonna say box. I'm gonna say width 150, height 150, and then we'll give them different backgrounds just so we can differentiate them. So I'm gonna say box and child, right, 1, yes, and I'm gonna do the same here. Beautiful, right? So we have 2 different boxes, right? A red one and a green one, right? Then I'm gonna make sure that they are in next to each other. So I'm gonna say display inline block, if you remember from our previous video. So now they're next to each other, right? So as you can see, these boxes now have fixed size. They're 150 pixels width and wide and high, right? What if we wanted to tell these guys to always be the size relative to their parent or the whole document, right? So what if this container that we have was 900 pixels, right? So we say width 900 pixels and background color blue, right? So what if we wanted to say, hey, well, boxes, I always want you to take the certain percentage of this? Well, obviously we would use percentage, right? So let's see what happens if I come here and I say, hey, I want you to be both 40% width, right? And we obviously need height to be fixed here because there's no content, unfortunately. So here I'm going to say height is 200 pixels, right? So as you can see now, and just actually, I think I skipped over something. So the reason why we have to set the height to some fixed value right now, just so you don't get confused, is like, hey, Alex, why can't we set height to 40%, for instance? Well, we can't because our also boxes don't have any content inside. So if we set it to 40%, we would need to have some content as well. So I would need to come here and say lorem, 10, and here do the same lorem 10, right? So if I actually get back over here, let's see what happens now. So as you can see now, things are slightly different now, right? And if we take a look at this, you can see that where did we do that? Box with height 40, right? So you can see that because this one has a little bit more content, right? It's a little bit larger, right? This is, if we increase if we add more letters here, right? So if we do this, oops, let's say lorem 10 more words, you'll see that this is going to grow. So what is the problem here, right? So why is this happening like this? Because you can see that Alex, why is 40% in height neglected, right? Well, 40% of what, right? So this is an interesting one. So as here I'm saying 40% height should be 40%, but 40% of what? Our container doesn't have height set on it, right? If I actually go to compute it here, and if I just do this, if I search for height, right, we will see that the height is 240 pixels, but the height is basically whatever the content is taking. So how could we actually tell this guy to be height 40%? Well, we would have to set the height on the container as well, right? So if we get over here and say 500, right? Now this changes a little bit, right? This slightly changes, right? And as we can see here, you can see that this is now respected. You can see that the box now has in fact 40% of height. Let's actually make it 20% just so this is more apparent, right? So you can see that the box now is staying 20% of the height, and the rest of the content is kind of leaking out, if I may, right? So in order to obviously use percentages in width and height, you need your parent or some element that the percentage should be relative to has to have fixed width and height, right? So as you can see, if I remove the height from here, then, well, this 40% height doesn't do anything, right? So that's more or less basically that. Now, as I was saying, so I'm going to actually remove the height. I don't care about the height for now. As you can see here, now we're saying, hey boxes, I want you, each one of you should be 40% of the total width of the parent. So as you can see, if we actually make this 1000 pixels, it's going to be easier for us to understand. We now know that each one of these boxes is 400 pixels wide, because 40% of 100 would be, in this context, 400, right? So as you can see here, if we take a look at the width, so if we get over here, actually we go to compute it again, and we search for a width. You can see here, hopefully, that the width is 400 pixels, right? So percentages are also dynamic values, but as we just saw, they're useless without being contained in something, because you have to know as a developer that, hey, I want this to be X% of something else. So, you know, if we didn't have this container, right, if we get rid of the container, then this would be 40% of the whole page, right? So the whole page now is, you know, the width of this page is, as we can see here, is 1280 pixels. Well, that's actually hard to believe because it's probably because of the zoom, but you can see now, if we take a look at the width of this now, and if I click on the box, and if we go here to compute it again, and we look at the width, right, the width is now 1017 pixels, right? So you can see, in most cases, you will be containing things inside of some divs which have some fixed width in pixels. And then you're going to be saying, okay, I have this, you know, on this resolution, on this screen, there's this box which is 1000 pixels, and I want these two things, or this one thing, or these 5 things to occupy 20% of the width each. And of course, you can't neglect the CSS box model that we learned about the last time, because yeah, you will have to account for these things and box sizing property, etc., etc. Because if you remember from one of our previous videos, if I put this back like this, what happens here if I set this to 50%, right? Before I refresh, you will probably notice now that, hey, these two boxes will occupy exactly the spacing in this box, but that's not going to be the case, right? You can see that they now can't fit, so they went below each other, right? The reason why it's actually a little bit weird that you can't see that they're actually below each other is because this content is different. So let me just do this. So you can see they're actually not occupying this. Why? Well, in one of the latest videos, we also learned that there's some quirks to the browsers, and we know that the divs by default add this 4 pixels of margin between each other. This is just the behavior of the browser, right? So if we remove that, you can see now that, oh wow, Alex, okay, so now they're actually occupying really, each one of them is now 500 pixels, right? If I would add, let's say, any padding or whatever to any of these boxes, right? What's gonna happen? Well, they will go beneath each other. Why? Well, because there's now exceeded width. The content cannot fit, because if you remember, since we're not using the box sizing right now, the elements grew to the outside. So this element is no longer 50%. This element is now 50% plus 10 to the left and 10 to the right. So this element is now 50. Yeah, so it's literally, in this case, it would be 520 pixels, right? I mean, if you don't trust me, what I can do here is I can say that this box here, the width of this is, you know, use this calculate function. Don't worry, we haven't done this, but we will. So here I can say minus 20 pixels instead, right? And now you can see they can fit again, right? But then even more importantly, why am I doing this now? Because I'm just trying to give you references to our previous videos. How can we fix this? Box sizing, right? If we would set the box sizing to border box, if you remember, boom, this is fixed, because now the CSS box model properties, borders, padding, etc., they're not added to the outside of the element. The content is taken away from within the content. You can see how in this red box, this text now has a little bit padding outside. To make this more apparent, let's say 50 pixels, right? You see now we have taken away from the content, and this is what box sizing is doing. So, and lastly, before we finalize this video, if you remember in the viewport video, we didn't cover the viewport width and viewport height. And as you can see here, logically, this is gonna use the size of the viewport. So if you remember what was the viewport, well, it's all of this available visible area, right? So if we switch these two boxes to be of that size, so here I'm gonna not say this, I'm gonna say VW, right? Now these things are supposed to take the width of the viewport, and the viewport basically is going to be, and let's just do, let's maybe say 49 view height. So you can see here, they're going to try to occupy the size always of the whole viewport, right? Of course, as I said before, the reason why we're having a little bit of these glitches is because the browser itself is setting some defaults, and it's kind of messing with us. So I'm going to reset some of these defaults that I know that they exist, because I happen to know that the body by default has 8 pixels of margin on all sides. So I'm going to do this. Let's now try to make sure that these elements are actually now 50% of view height. And as you can see now, these two boxes are always going to occupy the well, together combined the whole view width, right? But as I decrease the screen, of course, they will always follow, because no matter the screen, we're saying, well, always occupy it no matter which resolution you're on, right? So that's how it works. I guess logical question here would be, Alex, what would be the difference between percentages and view width or view height, right? Because at this point in time, right, we haven't really seen that. If I set this to 50% percentage, right, it's going to do the same thing. And the difference is, in this specific context right now, difference is neglectable. It's meaningless, because this is a very bottom-up approach of teaching you this. So in this context, there's none. But you will not be using view width and view height for containing elements inside of the parent. You're going to be using these view heights, view widths. You're going to be using viewport for a general layout, right? So you're going to be doing that for your entire layout, for your how to organize a layout on specific viewports. But you're not going to be using that as we had this container example a second ago, right? Where we were containing, you know, things inside of this container, right? Why? Because you will not, that's impossible to calculate, right? Because if you say inside of this box, hey, I want this red box to be 30% of the view height, you're not saying you want to be 30% of available space in this blue box. You're saying 30% of this whole white area width, right? The one that I'm showing in my cursor. So that would be very difficult for one brains to calculate, right? Because if I now said, hey, this red box be you know, width of 20 view width, right? well, what is that? Well, 20 view width is actually 20, let's say almost 20% of the whole available thing. So this white box here, right? So it makes no sense. That would be very difficult for you, for the developer to reason about, and it would be even more difficult for someone else to read, because, okay, so he has this box, which is 960 pixels width, but the viewport, you know, is relative. The viewport width is relative to the device size. So, you know, sometimes the viewport is going to be huge because I might open this website on a huge 60-inch TV, and sometimes I might open it on my cell phone, right? So it would be very difficult to calculate. So the difference between percentage and viewport and view height is that percentages you will use to really add sizing to the elements which are contained inside of some of the containers that do have some fixed size for the most part, and then your brain is going to be able to say, hey, I have this div, I have those 3 boxes, and I want them to be 33% each, right? So for example, that's a very common thing. Imagine we had like 3 of these boxes, right? And I wanted to put them next to each other, and I wanted them all to be, equal in size, right? You would do this, right? And as you can see now, they are in fact next to each other, right? And then you could add padding to them or whatever to remove some stuff, right? If I actually remove these super awkward colors, now you have these 3 boxes next to each other, but you are calculating the size in your brain relative to the container that contains them. So you know now that, hey, the width of these boxes, each one is 333 pixels wide, right? Instead of needing to if I said 33% view width, right? Well, that's now different, right? That's slightly different. Now I have to say, what is the 33% of this whole thing, right? So that would be not very easy to figure out, right? Okay, so that's it, I think, for this video. We covered most of the CSS units. I think there are probably more, but you'll not use them. For the closure of this video, if I may, you will not be using these units way too much. You will not be fiddling too much with the view height and view width. There's going to be exceptions when we're doing more complicated layouts for sure, but it's going to be not going to be a regular thing you're going to be doing. What you're going to be doing a lot is using pixels. You're going to be using percentages a lot as well. EMs and REMs, it's questionable, not so much. A lot of the libraries out there might use them. And that's mainly because layouts become a little bit more complex when you start using these multiplying values, because one then has to map a lot of things in one's brain. Okay, so this element is this, but then on this resolution this multiplies this. So this is not to say that these units are bad or useless, absolutely the opposite. I think people who are more educated in CSS, people who are awesome at building layouts, they will use these units because they can compose the layout easier in their minds and then write these calculations and stuff. Most people, especially junior people, they're more prone to use pixels because that doesn't multiply anything. You literally say, I want this to be this big, and then you use media queries that we're going to learn about and stuff later to say, okay, on this screen, this should no longer be 1000 pixels, now it should be 500 pixels, but still you're kind of not calculating, you're not multiplying things, right? So nothing is really dynamic. That marks the end of this video. Please read the documents that I provided. Yeah, go through the video, ask any questions if you have here on YouTube, and yeah, sign up on Programmer Network, join our Discord, join my streams in the evening when I have the time, and that's all for now, fellas. I wish you best. Thank you for watching, and I'll catch you in another one. Peace out. Cheers. Bye-bye.